So we're going to be talking about what's called the shell method for finding the volume of solids of revolution. And the principle is illustrated really well by this picture. So we might have, as we do here, an area under a curve. And we're taking this particular area and rotating it around the y-axis. When we do that, we end up getting a shape, and the shape that we get will look something like this. And in the past, what you've done is you've considered this in terms of, say, stacks of circles. So a picture might look something like this in terms of how you're picturing it, with holes cut out of it, right, using maybe the washer method. But now what we're doing is we're going to consider it in terms of what are called cylindrical shells, right? Or you can imagine we're slicing little pieces out of this, right? And so each of these pieces looks something like this, and those pieces have an area. And when we add up the area of all of those pieces, then we'll know the volume of our solid. Now this is a really useful technique if you have your expressions in terms of x, but your axis of rotation is y. Right? So now you can address it, particularly if you can't find the inverse function easily. Right? So sometimes it could be done using the washer method, and sometimes it just can't be done that way because of the algebraic manipulation involved. Another picture that can be helpful is this. So this is a picture of the shell itself on the left, and you could think of it like a soup can label. And if you were to unroll the soup can label, you should be able to recognize it as a rectangle, which is why, and it's important to notice that one side of the rectangle can be expressed as 2 pi r, or the circumference of the shell, and the other side of the rectangle is the height of the actual shell. Right? And notice how that is oriented in terms of the shell itself. Right? That's the picture we're after in terms of cylindrical shells. So that's the idea, and we'll start applying those ideas next.